Sometimes it's not always easy to balance redox equations using traditional methods, so instead we use a process called the ion-electron method. Now, the ion-electron method has a series of rules used for balancing. We're only going to be doing it in acidic conditions. Now, this can be recognised by the presence of hydrogen ions in the skeleton equation. So step number 1 is to have the unbalanced equation for the reaction. This is the skeleton equation. It only contains the important components. Step 2 is to divide the overall reaction to 2 unbalanced reactions, one for oxidation and one for reduction. Now you can identify which component goes to which by using your oxidation numbers to identify what's undergone oxidation and what's undergone reduction. We balance for all the elements other than hydrogen and oxygen. Then we balance for oxygen by adding in water, and we balance for hydrogen by adding hydrogen ions. We balance for charge by adding electrons which are negatively charged to the side which has the most positive charge. We multiply the two half reactions by the coefficients of the electrons, because all electrons produced by oxidation must be consumed by reduction. We add the two half reactions together and we simplify the equation. Now let's balance this unbalanced equation. Now this is currently what we call a skeleton equation. You can see that it contains the important components. It also tells us that this is in acidic conditions by the presence of the hydrogen ions. Now we're ready to divide our unbalanced skeleton equation into two half reactions. In order to do this, we need to use our oxidation numbers. So I go through and I put in all my oxidation numbers. So let's have a look. In this case, the oxygen is -2, each of the hydrogens is +1, +2 for iron, +2 for here, +3 for here. Now I don't know what manganese is, so over in the corner I'm going to work it out. Manganese plus 4 oxygen equals -1. Manganese plus 4 lots of -2 equals -1. Manganese plus -8 equals -1. So manganese must equal +8 take 1, which equals +7. And I write that in. Now I can see quite clearly here that the manganese in the permanganate has undergone reduction because it's gone from +7 to +2. And the iron 2 has undergone oxidation because it's gone from +2 to +3. So I can now break it up into my two half reactions, one for oxidation, and that's Fe2 plus goes to Fe3 plus, and one for reduction, and that is permanganate goes to Mn2 plus. Now that we have broken it up into our two half equations, let's just balance the oxidation half equation. So the first step is to check and balance elements other than oxygen and hydrogen. Now in this case, our elements other than oxygen and hydrogen are iron, and you can see I've got one iron here and one iron here, so it is balanced. Now we balance for oxygen by adding in water, and by balance for hydrogen by adding in hydrogen ions. In this case there are no oxygens or hydrogens, so it is actually balanced. Now we have to add electrons to the side which has the greater positive charge. In this case the reactants have a charge of +2 and the products have a charge of +3. As we're adding electrons, and each electron has a charge of -1, we have to add the electron to this side, because now +3 plus -1 equals +2, and you can see that the charge is now balanced. Now let's balance the reduction half equation. We first of all balance for elements other than hydrogen and oxygen. In this case, we've got one manganese here and one manganese here. So that is balanced. Now we need to balance for oxygen and hydrogen. Now to balance for oxygen, we add in water. So this side currently has 4 oxygen and this side has none. So we go add 4 water. Now we balance for hydrogens by adding in hydrogen ions. This side has 4 times 2 is 8 hydrogens. So to the reactant side we add 8 hydrogen ions. Now that we've balanced our matter, we must balance our charge. So, to the reactant side, this one has a charge of -1 plus 8 lots of +1. So -1 plus 8 lots of +1, the reactant side has a charge of +7. On this side, we've got +2, add 4 lots of 0 for a compound, so this side has an overall charge of +2. We have to add electrons to the most positive side, remembering an electron has a charge of -1. So this tells me I need to add 5 electrons to the reactant side, so 5 lots of -1. 7 plus 5 lots of -1 comes out to +2, and we have balance for charge. Now that we've balanced for charge, we have to make sure our electrons are equal for the oxidation and the reduction, because all electrons produced from oxidation must be consumed in the reduction. So at the moment, this one is telling us only 1 electron has been produced, but 5 have been consumed. So we need to multiply the oxidation reaction by 5. So this would give us 5 Fe2 plus, 5 Fe3 plus, and 5 electrons. Now we've got the same number of electrons being produced by oxidation as being consumed by reduction. Now that we've got the same number of electrons on both sides, we now add the thing together. So it becomes a big add up. We add the reactants together and we add the products together. So adding the reactants, we have 5 Fe2 plus, add permanganate, add 8 hydrogen ions, add 5 electrons, goes to 5 Fe3 plus, add 5 electrons, add Mn2 plus, add 4 water. Now we go through and eliminate the species that are on both sides. In this case, we've got 5 electrons on both sides, so we can cross them out. We rewrite the final equation, putting in all state symbols, so 5 iron 2 ions plus a permanganate ion plus 8 hydrogen ions goes to Mn2 plus ions plus 4 water. Our final step is just to check. Now we can check by doing our standard, oh, I've forgotten to write in my 5 iron 3. So just as well I did a check, because otherwise it wouldn't have worked. So I've got 5 irons, 1 manganese, 1 manganese. I've got 4 oxygens here, 4 oxygen here, 8 hydrogens. Check the charge. 5 times 2 plus is 10 plus. Take 1 is 9 plus. Add 8 is 17 plus. This is 5 threes are 15 plus. Add 2 plus is 17 plus, so it's balanced. Now it's important that you try some yourself. I want you to go to the OneNote, try the first couple of examples of balancing ion electron methods. There's only 2 examples at this point. We'll do the rest in class together, and you can check how you went by going to Space, clicking on the redox, and find the YouTube links on me doing the same questions.